Okay, yeah, I'm Dave. A lot of my colleagues call me D Herman. That's my GitHub ID. That's my IRC nick. I'm Little Calculist on Twitter, which is a long story. You don't want to know where that comes from. So that's where you can find me. And I love JavaScript. I think it's a fabulous language. It's got some really brilliant ideas in it. And it's also got a few bad parts that people have been known to talk about. So I love JavaScript for the language that it is and for the language that it really wants to be. So that's a big part of why I serve on ECMA, the organization that Doug mentioned, where I represent Mozilla. You just heard this. You know this. All right, life is short. Let's get to the dessert first. What you want to know is what's going to be awesome about the next version of JavaScript. So this is my whole talk in one slide. This is what I'm going to talk about. There's so much awesomeness coming in ECMAScript edition 6, which will be the next version of the standard, that I figured I'd just start with the stuff that I thought was the absolute most awesome parts, the parts that I am the most excited about. That's Batman. And there's going to be a lot of code on these slides, so I hope everybody's had their coffee. You may start to go cross-eyed at some point, and that's OK. Yeah, we're going to talk about modules, block scoping, generators, proxies, binary data, finally, destructuring, REST args, and defaults. This stuff, you got to give Robin his credit. Like, he's still pretty awesome. He's not Batman, but this stuff is going to be awesome, too. So I hope you won't get bored at some point in the talk. But if you do, that's OK. Just don't tell me. All right, but I will sum up when I get to the end. So for those who kind of get tired of the code samples, I'll try to give you the big picture too. All right, so let's just go straight into it and start with modules. What are modules about? Modules are about libraries. JavaScript has had a few massively successful libraries sort of earlier on in its history. Obviously, YUI is one of those. But there was a small number of the really big ones that really took off. And in the last couple of years, particularly since the invention of CommonJS, which is a sort of lightweight standard for a sort of module pattern, people have started to figure out easier ways, standard ways of sharing their code. And we're starting to see more and more libraries on the web. But I still think that there's a lot of friction caused by the fact that there's no one standard way in the language itself to create some code that you want to share with other people that they can just mix and match and compose with the rest of their code. So to be truly great, to fulfill its potential, I think JavaScript needs a module system built in. And this is the feature that I'm probably the single feature that I'm most excited about in ECMAScript edition 6. So here's one way that I think about modules in JavaScript. When you start with a brand new web page, when you sort of start with that blank screen or that skeleton HTML file, the browser basically hands you a lump of clay. And we have learned over the years, especially with the help of evangelists like Doug, who've taught us good patterns and good ways of using the language, that ball of clay is incredibly malleable. There's a lot of stuff that you can do with it. But every new page that you get is just an unshaped lump of clay, and you have to start from scratch. So that arm is the browser, and that ball of clay is an empty script tag. We go through this process every single time. We have ways of shaping these balls of clay. We've learned from Doug the module pattern. Excuse me. So if you want to create a module and you want to share it with somebody, this is. I didn't hear.
That's the dog balls.
Oh, this is the dog balls. Oh. I didn't need to know that. All right, then. How do you follow that? So this is probably going to be an easy crowd to sell that this is maybe not the ideal code. Yeah, I mean, this is how you write a simple module in JavaScript. And you have to go through all of this work. You have to make sure to protect your scope so you don't accidentally create global variables. You have to package up an object that contains all the exports that you want to ship out to the external code. And there's a million little tiny variations on this pattern, and so there's not really one standard way of doing things. And I'm a language nerd, so whenever I hear about patterns, I think of this quote from Paul Graham where he said, there's a longer quote, but he said essentially, whenever I hear about design patterns, I wonder if this is not an instance of the human compiler at work. What he means is whenever you're writing the same boilerplate over and over and over again, you're kind of acting like a piece of software. Shouldn't we automate the processes that we're doing the same way over and over and over again? That's exactly what a compiler does. So I don't want to be a human compiler. I want to let the compiler be a compiler. I don't know if anybody has ever actually said this, but I like to think of design patterns as the sincerest form of feature request. When programmers are writing the same boilerplate code over and over and over again, they're saying there's something missing in this language that I wish that it had, and this is my workaround. But it would be nice if I didn't have to work around it. So if we just had modules directly in the language where you could say module collections, you could just write the code sort of the way you meant it. You could decide what you wanted to export simply with an export keyword. This already looks a lot cleaner. It looks a lot more like the intent of the code. The module system that we're working on also lets you easily import the exports from another module. And it even lets you import from external files, similar to the script tag in the web. Now you could actually do this from within JavaScript itself. So that's useful on the web. It's also useful in other environments like Node.js, where Node.js has to rely on CommonJS to get access to external files. Node.js doesn't have script tags where it can say what files it wants to get. So having a way actually within JavaScript to load external modules means that this works on the server side as well as it works on the client side. And there's an important detail here which CommonJS couldn't do because they didn't have the option of changing the programming language itself. They didn't have the option of changing JavaScript, which is what our job is on this committee. And that is the ability to preload these external files. So part of the model of doing I/O in JavaScript, as we all know, and I'll talk about this more later, is that you never do any kind of I/O in a blocking way. You never stop your script partway in the middle and block waiting for some bits to come in over the wire without using a callback where you actually explicitly suspend your code. Here, we're actually writing the code in what looks like a blocking style, but the important thing is that this happens actually before any of the code runs. So it's not going to preempt your code at various points. And that also means that you kind of you give the browser the ability to do things like prefetching. So the browser can look at the source code, and it can start prefetching the other scripts that you're loading. OK, so I could talk a lot more about modules, but we have lots to talk about. Here's another one that I think is it's been a long time coming, and that's block scoping. Here's the slogan. Here's the way to think about ES6. Let is the new var. Our goal with ES6 is for you to basically be able to just kiss var goodbye. We're not actually going to throw var away. We don't want to break all the existing code on the web. But whenever you write a new program, you should never have to use var again. Let will just sort of work the way we all wish var did. And this is my favorite example of the classic newbie mistake in JavaScript. You have some loop that binds what looks like a local variable, and you create a bunch of closures each time through the loop referring to that local variable. And oops, it turns out that that's not a local variable at all. That was hoisted to the entire function body. So Doug teaches people you should actually manually hoist your vars so that it's absolutely clear in your code where they're actually in scope. But with let, you can actually write the code the way you wanted to. You can have a local variable inside of the block, and this does what you want. So let is like var, except that it's block scoped instead of function scoped. This is sort of the way var should have been from the get-go. Now we're going to do it. SpiderMonkey has actually had this feature for years. It just was part of the ECMAScript edition 4 process that got canceled, so it's taken a few years to bring it back through the standardization process. OK, so I mentioned I/O, blocking I/O before, and that's the next topic. I'm curious, how many people here have used Python at all? And of those people, how many people have used Python generators? A small number. OK, so it's not particularly commonly used. That's cool. So I'm going to talk a little bit about how generators, I think, can be a viable alternative to callbacks. So if you've never seen generators before, this is roughly what they look like. They're actually very similar to the feature from Python. A generator function is like a normal function, except it has this star symbol next to the word function that just indicates this is a slightly special kind of function. The thing about a generator function is you can suspend in the middle of what you were doing and re-enter the function at an arbitrary point later on in the program. And the way you do that is with the yield keyword. So this is like one of the simplest generators you could write. It says yield 3 times. So how do you use that? Well, you call the function, and what you get back is a suspension of the function. It actually hasn't even started running yet. It's called a generator object, and that's what we're binding to G here. And you can resume execution of that function anytime you want by calling the next method on this generator object. And that'll start running the function again, and it'll stop as soon as it hits the next yield. So this creates a way that you can write functions where you can say at any point, I want to stop what I was doing, and I'll continue later. And that's always totally manifest locally in the function because of the yield keyword. Nobody else can ever yield you. So you can't call some other function that yields you. OK, so this one, we call next 3 times, and we get 1, 2, and 3. OK, what does that have to do with callbacks? All right, first of all, OK, in the last conference I went to, I said, we've all seen code like this, and some smart aleck tweeted, no, I haven't. So I actually looked at the YUI documentation page yesterday, and there's one of these on the front page. But is there anybody here who has never seen code shaped like this? OK, so I think I'm right here, that this is a pretty common phenomenon. I like to call this the pyramid of doom. This is what happens when you want to do a bunch of things sequentially, but they're only after finishing some blocking I/O operation from the previous thing. You end up writing in what pointy-headed language nerds call continuation passing style. Each one of these operations takes a function that you call a continuation that is, here's what to do when I'm finished with this previous operation. So this code is pretty mucky. It can be hard to read. It can be hard to work with. It can be hard to change as the flow of the sequential operations you're doing needs to change. Some people like to say, oh, come on, if you have these big pyramids, you just need to learn how to hoist your functions out. OK, well, you can hoist your functions out one at a time, give each one a separate name. It's not totally clear to me that this code is that much more readable than the previous code. Not to mention the fact that you end up having to copy all of the whatever local variables you needed to refer to in any of those nested functions now need to get copied into the parameter lists so you can get this explosion of additional arguments. And besides, like, this is supposed to represent a sequential control flow. I mean, thank God we don't do this in the rest of our lives. Imagine if we had to write our recipes this way. Step 1, page 1. Go to page 2, step 2. So how can generators help with this? Well, generators give you this ability to say, I need to stop what I was doing and wait for something to happen later. And that's exactly what you're doing with callback-based I/O, with non-blocking I/O. You're saying, there's some operation that needs to finish before I can proceed with what I was going to do. So I've actually played around with a library that actually provides some conveniences on top of this. This idea of using generators as a way of doing non-blocking I/O. It's called task.js. You can find it on GitHub. It's not in production-ready state, but it's just an experiment. And it's open source. I welcome anybody who wants to play around with this with me to join me. And the idea is I have this spawn function that'll take a generator function and basically put it into a scheduler. And every time you yield from what I call your task function, you just send it a promise. So a promise is something that's starting to catch on in some other JavaScript libraries like jQuery and Dojo. I couldn't find it on the YUI page. I think YUI doesn't have promises at this stage. I'm not sure if there's a plan for that. But the idea of a promise is it's just sort of a representation of, it's a value that represents I'm waiting on some data to come in later on. So if you have a promise API for reading over an XML HTTP request, or a promise API for set timeout, that promise gets passed into the scheduler, and the scheduler decides to wake this task back up as soon as the promise is ready, as soon as the promise is fulfilled. So what ended up with the Pyramid of Doom or with these many, many different callbacks with names that are hoisted to the top level actually goes back to looking like normal straight line sequential code. And the yield keyword is what tells you at each point, this is where we're actually blocking waiting on I/O. So I'm really excited about generators. I think they're a nice sweet spot that allow us to still have an explicit way of saying, I'm suspending what I'm doing here. Yield still makes that clear. You could contrast that with Java, where with multi-threading, at any point, anywhere, somebody could preempt you. The system scheduler could preempt you, and you never know when your state could be changing out from under your back. Here, it can only happen when you decide to allow it. So this is sort of like cooperative multi-threading. So I think this is going to be really powerful. I hope that people will experiment with more scheduling libraries like Task.js. The fact that you can write your own scheduler also means you can do fun things like, this is on my to-do list, I haven't done this yet, but I want to have a record and replay version of Task.js where I actually, if you go into recording mode, you can actually create a history log of every I/O operation that happened in your test run, and then that becomes a replayable test that you can put into your test suite to get a deterministic sequence of I/O operations in your program. So that could be useful for testing. I think there's lots of experiments people will do with generators. Next topic is proxies. Proxies are a pretty powerful metaprogramming API. They're actually a super powerful metaprogramming API. And they've gone through several iterations of API design. And there's a more recent version of the API we've been discussing now that I think is actually a little more approachable than earlier versions. So I'm showing you something like what we think they might look like now. But this is still ongoing work. A proxy basically lets you take some existing object and create a wrapper object that can monitor anything that happens to that object. So you can intercept get operations, set operations, delete operations, just about anything you can ever do with an object. You can actually create a monitor function that will be triggered whenever anybody tries to do something with the underlying object. So one example people have talked about a lot for what you might do with proxies is data binding. So if you want to create some data collection in some place and you want to be able to respond to that, say in your UI, you want your UI to automatically update when the data changes, you could wrap that data in a proxy and basically respond to these data change events that happen on the object. Another thing you can do with a proxy is you can actually self-host a lot more of the JavaScript language. So the DOM is this crazy library that has objects that don't behave like normal JavaScript objects. We've actually built a faithful re-implementation of the entire DOM in pure JavaScript at Mozilla because proxies are so powerful, they're so flexible that you can write, you can create sort of your own object semantics. So this one is a pretty low-level API, and it solves a few important needs. There are also some security patterns that proxies can be really useful for. So when you're sending out some data to untrusted code, you can wrap it with a proxy that makes sure that only the select operations you want to allow to happen. So I think it's going to take people a while to experiment with this, but it's such a powerful feature. I think we're going to see a lot of creativity around proxies. So kind of getting out of abstract land into more concrete land, binary data has just been a sore spot in JavaScript for a long time. Node.js has really struggled with this. They had to create their own hooks for binary data because there was nothing in the language. And we're seeing this in web standards as well. There are these typed arrays that kind of don't have a standard yet to live in. They were invented for WebGL. And typed arrays are powerful. They give you the ability to interact with binary data, but they have some usability issues. So what we tried to do was to take typed arrays and kind of make them a little more fully featured. So what we did was we created a library of first-class binary data types. So you can actually create a data descriptor yourself in your code. So here's an example of a struct type where it's a JavaScript value that describes structs that have an X field and a Y field that are both uint32s. And here's another struct type that's a color struct that has 3 unsigned 8-bit integers. So these are data descriptors. They're not themselves structs. They're just sort of struct types described in JavaScript. You can also combine these struct types. So you can create a struct type pixel that combines both the point2D and the color that I showed on the previous slide. And you can also create array types. So here's triangle is an array type with 3 elements, each of which is a pixel. Okay, so these are ways that you can mix and match these type descriptors. Well, what do you do with a type descriptor? It's actually a constructor that you can call to construct a binary data object. It's a JavaScript object, but it's actually encapsulating compactly allocated binary data. So this alone could be useful for doing things like crypto algorithms that need to do a whole bunch of hashing over binary data and need to have a really compact representation to be efficient. But it also is something, I don't have slides for that, but it's also something that we're going to make compatible with the various I/O specs on the web, like HTML5 file API, WebGL. I'm hoping that Node will integrate this as well once it gets built into V8. So the idea here is once you have a way of actually controlling the exact representation of binary data, now you can interface with the outside world. So you can do things like reading from a file or writing to a file, reading from a network socket, writing to a network socket that needs to be in a very specific binary format. This is just something that you couldn't really do with JavaScript, except maybe in very clunky ways if people built in special hooks. Destructuring is one that is kind of, in my experience, when they first look at it, people often don't understand what it is or can't really see the benefit. But almost universally, I don't think I've ever heard anybody who started using destructuring who didn't like totally fall in love with it. So try it, you're going to like it. Destructuring lets you eliminate a huge amount of boilerplate code for taking some compound data structure and pulling out its pieces. So here's an example of thing.color is some object, or we're expecting it to be some object with fields called RG and B. I can just bind variables RG and B on the left-hand side here by automatically destructuring the thing on the right-hand side. So in this one line, I've basically said, ask for thing.color.r, ask for thing.color.g, and ask for thing.color.b, and assign each one of those to a local variable RG and B. So it's really concise, but it's also really readable. I mean, basically, you're creating a pattern on the left-hand side that sort of matches the pattern of the data that you expect on the right-hand side. You can do the same thing with arrays. So you can say, I expect circle.center to be a 2-element array, and I want to ask for circle.center bracket 0, circle.center bracket 1. But all of those individual accesses are just elided here, and the code just looks like sort of how you envision the pattern of the actual data. There's tricks you can do too, like you can do automatic swapping of 2 variables by pattern matching without actually having to name the temporary variable. That's mostly a stupid human trick. But destructuring works in more places than variable bindings. You can also use it in your function signatures. So if you have a function that takes an options object, instead of having to name it options and destructure the object one piece at a time, you can actually destructure directly in the head of the function. So this is just nice and concise. It says just what you meant. Those kind of conveniences continue with REST args and defaults. This is another sort of addressing a JavaScript misdesign. Is that a little harsh? I hate the arguments object. I wish the arguments object would die. So the arguments object is really painful if you want a few fixed arguments and then the rest. And in ES6, you'll just be able to say that directly. You can say I, j, and then ... rest means however many more arguments there are, I want them to be packaged up in an array. The other thing that we'll get right, which arguments got wrong, is that it will be an actual instance of array, unlike the crazy arguments object. So you can call .slice on it without having to say array.prototype.slice.call of rest, et cetera, et cetera, et cetera. Yeah, I mean, it's a no-brainer. It gets better, though. You can also use the ... syntax when you're calling a function. So here we're calling array.push, and maybe we want to give it a few fixed arguments and then splice in the rest of the arguments. So you can do that with ... as well. You can use it with new also. This is interesting. This second line is not expressible. There's no way to write that code in ES3. And ES5, like, this is just sort of one of those weird language nerd things. The bind function, the bind method, actually gives you the ability to implement that code in ES5 in a way that you couldn't do in ES3. Apropos of nothing, just an interesting side point. Default arguments, or default values for arguments. So if you have an optional argument, width and height, and you want to be able to just say, here's the default value if somebody didn't provide the argument. Again, this just reads like what you meant it to say. So another no-brainer. And finally, this fits together with destructuring, so you can put defaults into destructuring patterns as well. So I can have an options object. My function takes an options object, and I can have optional elements of the options object and provide the defaults right there. So this is just pretty and concise and says what you mean. OK, I think we've moved on into Robin territory. So you have my permission to hate everything that I say, but I actually think that this stuff is still pretty cool. So name objects are a slight generalization of object keys. So in JavaScript, we all know an object key is just a string. Even arrays, array indices are actually converted to strings. So the only thing that you can key an object property with is a string. And that means that basically all the data inside of an object is always transparent. So if you ever want to do some sort of information hiding, any sort of encapsulation of data, say because you keep tripping over it, or you're trying to compose a couple of different objects and they're reusing the same name for different purposes and you don't want them to step on each other's toes, or you're in a security setting where you need to care about having some data that you don't leak to an untrusted third party. There's lots of different reasons why we use information hiding. And objects don't really give you a good way of doing it except with Doug's closures as objects pattern. So how do you do that? This is straight off of Doug's webpage. You create a constructor function and locally bind the private data inside the constructor function, and any of the methods that you want to have access have to be defined inside of the constructor body, right? We all know this pattern, but there's a serious downside to using this pattern, and that is that this .service here, this service method, there's a new closure being allocated for every single instance, and it's an own property. It's not a method that you can share on the prototype. So if you want to have private data in an object, if you want some private fields of an object, you're actually forced to create a new copy of each method, an own method for anything that accesses it. So there's a memory tax for doing that in JavaScript. So what we've done is we've created a very small generalization of object properties, which is that an object property can be more than just a string. It can also be one of these opaque name objects. A name object really doesn't have any data inside of it. It's just sort of a token that has a unique identity. So you can create as many new names as you want. And then once you have one of these names, you can use it as a property key. So here we create a new key. I'm just calling it key here. And that key is the name of the property where we're storing the secret data. Now I can actually share one single service method, because service is defined in scope of my definition of the key object. So now this one single method can be shared with all instances of container, but I haven't leaked the key to anybody. I can choose to give the key to whoever I want, but it's just locally scoped in this code, so it's not shared with anybody else. So private names give you a way of using objects to have private data in a way that doesn't force you to use closures if that's the wrong, if that doesn't give you the memory usage you want. Let's see. So custom object iteration. This is another one of JavaScript's features that are just clunky and hard to work with is the for-in loop. So part of our task was to see what could we do about reforming the for-in loop. So a common newbie mistake in JavaScript is to use a for-in loop on an array, expecting that you're going to get the elements of the array by value, not by key. But of course, if I have an array with 3, 4, and 5 in it, I'm going to get 0, 1, and 2. And a lot of code breaks because it expected that. Really, for-in just syntactically looks like it's saying, give me everything in this collection, when in fact what it's saying is, give me every key in this object. So we talked about reforming the for-in loop and ultimately decided that there was just too much of web code that was built around an understanding of for-in the way it works now. So we designed a different kind of loop that we call a for-of loop. So of is not actually a reserved word in the whole language, it's just contextual. So if you use of here in this one context, it'll understand this as a new kind of loop, but you can still have variables called of. So for of, by default with arrays, is going to give you the array values. For of, by default with other objects, we haven't decided. Maybe it actually won't do anything. Maybe it'll just throw because there's no actual iteration defined by default for objects. Or maybe we'll have it default to for in. If you have opinions about this, I'm happy to talk about them offline. We've been debating this lately. But the key here is that you can define whatever iteration protocol you actually want. We'll give you a few built-in ones. So keys will be an iterator we'll give you an iterator for any given object that gives you the object's keys. Values will give you an iterator for values. Items will give you an iterator for the pair of the key and the value. And here we're using destructuring in a nice way to pull out both the key and the value. But how do you write your own? We'll actually have a name object called iterate that you can put on any object you want, where you get to actually define the iteration protocol for this particular object. And you can share that on prototypes as well. So if you create your new custom collection class and you want to say, this is the way that my collections iterate in a for of loop, you simply define the iterate key on that prototype, and now every instance of that collection can be used in a for of loop to iterate over the values of that collection. So this actually leaves it up to the programmer to decide how they want a for of loop to work. Comprehension, and for those in the crowd who are Pythonistas, there were a bunch of you. Some of this stuff should look awfully familiar. We have ruthlessly poached ideas from Python wherever it's useful. And Python's not the only one. We've looked at CoffeeScript, at Ruby. We look at more egghead languages like ML and Haskell. We steal good ideas wherever we can find them. So comprehensions, anybody who's familiar with CoffeeScript or Python or even Haskell, these might look familiar. These are just a really beautiful and elegant way of doing array processing. So this first version here that has the square brackets is saying, I'm going to create an array whose elements are the multiplication of x times y, where x is pulled out of some iteration over object 1, and y is pulled out of some iteration over object 2. So it's sort of doing a map over these two different functions and automatically producing a new array. This is a really elegant way of doing array processing. We also have people in the community who don't like array comprehensions and who've said things like, I got so excited the first time I saw array comprehensions, I used them everywhere and my code became ugly. So I would say don't use them everywhere. In CoffeeScript, apparently you have to use them everywhere, but in JavaScript you won't. You can use comprehensions if you think they're good. If you don't like them, you can just use map for each, normal old for loops. You can do it however you like. But comprehensions are a really elegant way of doing a lot of simple array processing code. The second thing here is actually a really sweet syntax for doing a lazy comprehension. So what this does is it produces a generator object that has these next methods. So you can one by one pull out the elements of the sequence, and it'll only continue doing the processing each time you call the next method. So it's just like the code above, except that you kind of pull out values on demand. So if you're doing a really heavy computation, that can be nice as a way of just getting as much as you want or only doing the computation when you want to. OK, so the next topic is string templates. And so much of JavaScript code involves hacking on strings. I mean, we're embedded in HTML. We're generating HTML. And the only feature that JavaScript gives you for doing this is string literals and the plus operator. That's all you've got. So you could create string formatting libraries, and people do. And that's fine. But it really would be a lot nicer to just have a built-in way in the language of doing what's sometimes called string interpolation in languages like PHP or Perl or even Bash. It also relates to a feature called quasi-quoting from Lisp, although the people who designed this called these quasi-literals, and that term was so frightening that people got angry. So I just think of this as templating. I mean, this is what you're doing all the time. Whether you're doing server-side or client-side JavaScript, you're constantly creating HTML code that you need to embed some computed values into. And it's really nice to be able to create the string literal, but escape back out into JavaScript to compute whatever arbitrary values you want to splice back in. And for those who are paying close attention, you may notice that this actually is a multi-line string, and there are none of those evil line continuation backslashes that Doug may have talked about last night. Using the backtick instead of the ordinary quotes, that's how you do one of these new kinds of string literals. You just automatically get multi-line strings. So if you don't like the indentation aspect, which I've also heard Doug talk about, maybe these aren't for you. But it doesn't have the danger of the backtick with the secret white space afterwards. There's also an additional piece here, which is that often when you're generating templated code, you are introducing potential risk of various injection attacks, like SQL injection, script injection. And in addition to having the string literal, we also have a convenient way of being able to add your own sanitizers. And I believe we're going to be working on actually having some built-in sanitizers. I'm not sure if that's the case. But you can easily create, say, a safe HTML sanitizer that makes sure that there are no script tags. And there's just a convenient syntax for plugging that right in. And some very smart security researchers worked very hard on this and came up with something that they felt was both pretty simple and pretty robust for preventing string injection attacks. All right, here's another thing that you just can't do in JavaScript. This one's really painful. If you ever try to create a hash table where the keys are objects, JavaScript really does not help you. So you could do it with absurdly bad efficiency. You could store the elements of the table as an array and do a linear search every time somebody does a lookup, but that doesn't give you the efficiency that you expect of a hash table. So we're just going to build in hash tables to the language finally. So it's the current going name is map. A map is just a new object with get and set methods and some other conveniences like iteration. So you can store an object in there as the key and a value associated with it. Kind of a no-brainer, pretty straightforward. But we also have something that's a little more subtle, which is an API called weak maps. So weak maps let you store any object as a key with any value, but it's actually the reference is held weakly. So this is important for garbage collection, where if the object ends up getting garbage collected because it's if the object becomes unreachable anywhere else in the program other than in a weak map, the garbage collector will decide that this is actually an unreachable value, and it'll automatically make it disappear from the map. So that may not always be what you want. Sometimes you want a map where it really does hang on to this object strongly. But say, for example, you have a program like Yahoo Maps. That's Google Maps, sorry. Say you have some sort of anonymous mapping program. and you have a bunch of tiles on the screen, right? And we know how to do this. We lazily generate the tiles. We lazily download the tiles that we need as the user pans and zooms through the map. But once you start having too many tiles, you might want to start expelling some of those tiles because you don't want to fill up all your memory. So let's say at the same time you also have these markers for doing different searches. And the markers can come and go. Maybe you don't want to store those markers actually directly in the objects. You want to think of those as being separate, a separate data structure from the objects. But you want an association between each tile and what markers actually landed in that tile. With a weak map, you can create that association, say this tile corresponds to these markers, but if the tile ends up disappearing, because the user hasn't zoomed over there or panned over there for a while, and you eliminate the tile and the garbage collector decides it's time for the tile to go, the weak map will also make the tile disappear from the map. So this is one example. There's lots of subtle cases in sort of framework code where weak maps come up. Again, this is one of those sort of low-level power features. There's also some higher-level patterns that you can do with weak maps. For example, you can treat a weak map as a kind of private data field. So if you want some data that nobody else knows you're associating with this object, rather than putting it in the object, you can store it in this side table. Nobody has to know about this side table that you're hanging on to. But again, I expect the weak map isn't one of those things that people are going to reach for every problem. But sometimes for low-level code, framework code, or memory-intensive code, they can be indispensable. And there's no way to do this in JavaScript. There are no hooks to the garbage collector in JavaScript directly. Okay, that was the whirlwind tour of all of the features. But I want to reassure you that this is not just a grab bag here. We didn't just say, let's think of every cool idea we can ever think of and try to shove it into the language. There is a bigger picture. So first of all, we actually have a sort of mission. We have a main page on our wiki that sort of describes the overall goals of this process, the goals of what we're trying to do for ES6. And there's more than just this, but I think this is the heart of it. We're trying to make JavaScript a better language for complex applications because JavaScript programs in 2011 do not look like they did in 1996. We want it to be a better language for libraries because we want to support people creating bigger and better libraries like YUI. And we also want to support code generators. I haven't talked about that too much in this talk. For example, I didn't talk about proper tail calls, which I expect code generators might be able to make use of. Binary data might be useful for code generators. But code generation on the web is a fact of life, and it's not going to change. As much as I love JavaScript, I have no problem with people deciding that their language is better for their needs, and they would rather compile it to JavaScript. And that's, I think, a trend that's going to continue. So we want to support all of those use cases. So we're motivated by use cases, but one of the worst things that you can do in language design is say, I've got all these use cases, I'm going to find the first solution I can that solves it, and add them all together, and that's my language. What you get with that is sort of Frankenstein's programming language. Instead, what you have to do is you have to say, how can we solve these features with the simplest, most general, and most composable features that we can? When you do that, you end up simplifying the language. You end up with sort of this as simple as possible, but no simpler programming language. And when you take all of those pieces and you put them back together, you also have to make sure that there's a cohesive design to the whole thing. So this is a process, and I brought this up in one of the TC39 meetings maybe about half a year ago. There's a concept I think it started in theology and then ended up kind of getting picked up in various branches of philosophy, this idea of the hermeneutic circle or the hermeneutic spiral. It was originally thought of as a way of, like I said, it was theological. It was like a way of reading the Bible, but it got generalized to sort of a way of thinking about learning, a way of thinking about epistemology. Whenever you're trying to understand something, you sort of study the individual pieces, and as you understand the individual pieces together, you understand the whole better. But as you understand the whole better, that gives you new insight into how to understand the individual pieces. So you kind of go around this circle over and over again. And I like the idea of the spiral because there's this idea that each time you start back over through the process, you're refining and getting closer and closer to your goal. So that's sort of how we work. We study the use cases, we study the individual pieces that we're working with, then we sort of take a step back and we have to look at how does all this stuff fit together. Then that ends up kind of feeding back into how we think about the individual pieces. So I showed you a whole bunch of features, but these are actually the culmination of years and years of work. Some of them are still ongoing work. But I think as a standards committee, we have our debates, but we actually work pretty well. And I think we all have a good eye for when things sort of are starting to feel like they've gone off the rails and how to cull back out complexity. The last piece is that we do our work in the open. And that means that every community that I talk to is a part of this process. So we're not doing this alone, we're doing this with the community. So we have an open wiki that shows all of the work that we're doing on the committee, and we have an open mailing list, es.discuss, which if you just search for es.discuss, you'll find the mailman information, where anybody can participate, and lots and lots of people do. Some people find es.discuss daunting. There's a lot of smart people. There's a lot of people with very firmly held opinions. But I promise you that I will take seriously any question that any of you has, and we all try to treat everybody with respect. And I think we actually have a pretty great group of people. The last question that I always get is, okay, fine, but I have a job to do. This all sounds neat and pretty, but when can I actually start to care about this? And that's a totally fair question. I mean, the standards process are working on a different timeline than you are in your day-to-day job. So IE6 is going to be around for a while. There's only so much I can do about it. That at Mozilla, we do our best to kill IE6. But So I think the best that we can do is the following answers. One, we have to work as fast as we can on this spec. The sooner we get this out, the sooner the browser vendors can start reliably shipping it, and that just will make that future where ES6 is a reality that much sooner. That's still not this year, though, so that doesn't immediately answer the question. But it's also important to recognize that we have a 2013 ship date for this spec. That's our goal for this spec. That doesn't mean all of these features are hitting browsers in 2013. In fact, a lot of the features I talked about today have been shipping in Firefox for a while. And V8 is doing serious work on this too. This is not just a Mozilla going it alone thing. Google is working very hard on a number of these features. So proxies are in both V8 and SpiderMonkey. Weak maps are in both V8 and SpiderMonkey. V8 just shipped maps and the companion library sets, which I didn't talk about. We are getting ready to land our first version of a patch for maps and sets. We have block scoping. V8's working hard on block scoping. So a lot of these features are actually landing a lot sooner than the spec. They may get tweaked as the spec stabilizes, but that means that these features are going to start landing pretty soon. The final piece is not something that I can hand you as a reality today, but it's a possible approach that Google has experimented with, and I would like to experiment with. I haven't had as much time as I hoped so far. And that's the idea of compiling to ES3, compiling to sort of the de facto standard JavaScript that reaches all the way back to IE6. A lot of the features that I've described here are actually pretty easy to kind of de-sugar, to just sort of rewrite into existing JavaScript. Things like destructuring or REST parameters. Those are actually pretty easy to compile. So we could make CoffeeScript-like transpilers for the new version of the language that you could use as a stopgap until enough browsers actually start shipping the standard language, so that you could actually be writing your code in the new language before the browsers actually support it. Again, this is not something that actually I have a working product here to hand you, but I do have an open source project called Narcissus that we have started working on this on. And anybody who's interested in languages, compilers, or the standards process, I encourage you to participate because it's actually a lot of fun to work on. So that's it. That's the future, and I think it's looking pretty bright. Thank you very much.